Hi, guys, and welcome back to another episode of Women in Math and STEM, where our mission is to reach out to as many professionals, aspiring professionals, students, whatever you name it. We try to reach out to them, who essentially support the initiative of bringing more women and young girls into the STEM field. So, with that being said, as always, feel free to open up the description or transcript to better follow along, and I hope you enjoyed this episode. Hello, and thank you so much for coming to this call and talking with me. Just to sort of start off, could you walk us through your sort of academic and personal journey that got you where you are today?
Yes, thank you so much for the invitation indeed. So I did my undergrad in Iran in physics, and then I moved to Germany and I did my master and PhD in Germany. And my undergrad was in physics. And when I moved to Germany, I was planning to study cosmology. So I started with the master in cosmology. But after once a year, I felt that I need more mathematical side of physics. So I moved to theoretical physics master program. And after that, in my PhD, I even moved more to mathematical side of theoretical physics. So my program was mathematics behind string theory. And after that, I started my postdoc in Switzerland and was always between like theoretical physics institute, a string theory group, or mathematical institute. So it depends on the countries and university. My topic could change either between physics or mathematics department. So then my full call is mathematical physics. So it depends on who I'm talking with. So I'm talking with the mathematicians. I'm telling them I'm a physicist. If I talk with a physicist, I tell them I'm a mathematician. So what I do is really in the border of theoretical physics and mathematics.
I see. How did you sort of discover that you wanted to study like physics for your undergrad?
Oh, this is a like little fun story that I had. It was some kind of physics competition for the high school student in my school. And we had one night of observatory. So we went out of town for some observatory night. And I fell in love with the sky and observation and all of this astronomical fact. So in my town, we had some institute that was private kind of institute belonged to city. So it was not part of schools or anything, and it was called the House of Astronomy. And I used to spend my spare time evening after school in that institute. And it was just a public place, people in different um, level and ages, they used to go there and they just meet and read some books about astronomy, some seminars. And it was the starting point. So from high school, I was 100% sure that I want to study physics, and that's why I decided to go to the physics department for my undergrad. So that was really the starting point, and motivation came from that environment and astronomy.
I see. That's pretty interesting. I think you also mentioned that you studied in Iran as well as Germany and like Switzerland. I was wondering like what the motivation was or like the inspiration was to like travel around and like learn and study in different countries.
Well, in Iran, studying science is maybe not as um, interesting compared to studying engineering. So that's why people, because they can find better job after studying engineering, people are motivated to go there to that direction. But in my case, I was really in love with physics from high school time, and I was sure that I want to continue my career until PhD. So I was not very worried about of stop my studying after undergrad and looking for a job. That's for something like physics, maybe it was not the easiest. So in my case, I was completely sure that I want to be a scientist and I want to continue in physics. So when I moved to Germany, of course, it was a bit of change of the system. In Iran, actually, we are more women in physics department, and in Germany was opposite. So the number of women was much less than number of the boys. So that was a bit strange for me. And of course, a little bit of change of system. I didn't used to have any lectures in English. So for me was new experience of going to the lectures that are in English, writing notes in English. And I was also in Germany and I didn't know German. So it was two new things so that I had to handle my life in with German language and handle studying in English that both were new. But I was part of international master program, so there were several international students in that program, so that make it life easier. And of course, first year was very challenging because I started with astronomy, which I thought I like it, but after a year, I felt that I really feeling the lack of pure mathematics, and I was not sure that this is the way I want to continue. Then I have to switch the program from astronomy to theoretical physics. So that was very challenging. And as I think I didn't answer your question. So as a difference is, of course, there is a little bit of difference of educational system, but it's also true that I also changed the level. So in Iran, I was a bachelor student, but in Germany, I was master student and then PhD student. So the system is also a bit, the level of education is also different. So I cannot compare because I was not PhD student in Iran or PhD student in Germany that I can compare. So it was different level. But it's, the good thing about science is the common language is the same. So that is the beauty, in my opinion, about science and mathematics, that people, they don't care about anything rather than the science and mathematics, and the common language is just math. So I like it very much in that sense, that I mean, people accept you because the only thing that they care is the math and science and not anything else. So
I think you also mentioned that you sort of like do work in like the intersection between math and physics. I was just wondering like what that sort of looks like compared to like somebody who just studies physics.
okay, so this is has its own beauty and difficulty in the same time. The nice thing about that is you learn the piece of physics that you like and piece of math that you like, and you try to be like the translator, like the bridge that connecting these two. So it's very interesting because you have to always find the same topic but in two different language that you explain about same topics, but sometimes it's physics language and sometimes math language, but the concept is the same. But the difficulty is, like, since you don't have infinite time, you cannot learn either of them so in deep. So sometime in the conferences, you feel a bit a stranger compared to the other people that are expert in one of the topics more than you. But of course, you know more and you are able to connect topics. So for me, this is actually very interesting, to be able to connect topics and relate math and physics rather than being pure physicists or pure mathematician. For me, this challenge was actually very, very attractive.
I see. Just sort of, I was also curious, like I noticed that you were sort of like a researcher as well as a scientist. I was wondering, based on your experience, what have been some of the more enjoyable and rewarding projects you had the opportunity to work on?
Oh, do you want me to explain about the project? Because it's a bit, I think I cannot not explain it for high school level students. So
Oh, it's okay. I'm just curious. It's like, um, if I don't
okay,
understand it, I'll let you know.
I see. So let me explain like that. My field, what is like in more precise topics that I'm working on, it's called quantum topology, and it's already showing that is something between intersection of math and physics, actually. So the quantum part coming from the quantum mechanics, that is very important topic, that is like one of the main topics in physics. And topology is very important and one of the core topics in mathematics. And what I do something as a combination of that. So people that are about the mathematics that is can be connect this quantum mechanics, they do more like experimental, and they use this quantum physics in some topics like condensed matter or quantum optic, and something that is more practical. But what I do, I use this quantum mechanic as some abstract language and connect it to another topic in mathematics that is called topology. And we are studying something that is exactly in the crossroad between math and physics. So this is one of the example, and this is exactly the precise topic that I'm working on that, and it's called quantum topology.
Oh, okay, that sounds really interesting. It also seems very complicated. I was just wondering sort of if you had any pieces of advice, suggestions, recommendations, resources, honestly anything for students who are interested in sort of pursuing either physics, math, or something related to STEM in the future.
Okay, so in that sense, it's like, from my experience is, at least in my time, that was a long time ago when I was high school student, maybe parents, they were not very they were very worried about their children going to study science, because they felt that if you study engineering, for example, is like more promising for finding job. And I didn't have this problem with my parents, luckily, and they were okay with me studying physics because I was really in love with pure science. But when the time passed, I feel even it was a very good choice. And actually, I feel that the science is making your really teaching you the way of thinking. And when you spend time in research and learning how to research, is actually teach you how to solve the problem. So it teaches you problem solving, and you can use these skills in any other direction that you go on in the future. So even if you start working in some engineering company, you have some skills that is very valuable. And this is one of the reasons, actually, recently, very high-tech companies, when they want to hire people, they actually very much prefer to hire people that study pure math or physics as a scientist, rather than the people that they were just from the beginning engineers. Because people are studying pure science, they learn some skills as this problem solving that is in practice become more useful for the company. So in my opinion, this is very, very important that the student, they learn how to solve the problem, and they find their own way to train themselves, and depends on the question that they have to solve, they find the best approach to train themselves, learn by themselves, and find the best and fastest way to solve the problem. And this skill can be useful in private life and also for professional life. And also with this new AI technology that we have these days, a lot of jobs would be replaced by robots, as we know. And I think that one of those topics that is replacing by robots and AI much later than the other would be pure math and pure physics. That is still a bit far from replacements of the robot by human, because they still need a lots of creativity and analyzing that it still needs a human brain. I have no idea if mathematicians and physicists can be also replaced by robots. I believe the answer is yes, but I think the timing of that is a bit further than other type of jobs.
I see. I was just wondering, since you mentioned problem solving, what are some sort of good ways to like develop those sort of skills that like are useful in math and physics?
Well, okay, it depends. If depends on the level of your education, the answer to this question can be different. If you are a high school student, of course, you have to just follow your school's exercises and the system of your school and try to always accept the challenge that you have by yourself and just be persistent and of solving the exercises that you have at school, rather than just try to Google it, because of course the answer of the questions you can always find them online, but the process that your brain cells develop is coming by the challenging that you give to yourself by solving the exercises that is given in the course. So this is in the level when you're a high school student or undergrad, that you have a lot of a specific course with a fixed exercises and the answers are known. So the answers are everywhere, but the challenge that you give to yourself and try to solve it by yourself, and even if it takes longer, just be patient and insist and try rather than try to find the solution fast. Because when you see the solution, oh yes, it's okay, it is like that. But the challenge that you give to yourself and the time that you spend is really train your brain cells. So this is that level. But if, of course, if you are in the higher level and you are researchers, so you're facing the questions that you don't know the answer. So then the challenge is exactly that you are trying to solve the questions that you don't know the answer, no one knows the answer, there is no way that you can search that answer. And sometimes even the more difficulties is you don't know if the answer exists or not. So even answering the good questions become very important. So you have to find questions that are valuable to answer. So these are two different technique that you have to learn. Ask good questions, and if you have good questions, find a way to answer it. And it happened in the history mathematics. Some people that they give very important questions, that there are some of them are still open questions. So people still they don't know the answer. They call it conjecture. And conjecture means that there are some mathematical questions that people they know that is true, but they don't know how to prove it. And it sometimes is some decades and years and pass, and people they still don't know the answer, and then someone find the way to prove that conjecture, and the conjecture after it's proven is become theorem. So people change the name of conjecture for the open math question, and when they are able to prove it, they change it to theorem. And even after they prove it, it might happen that the proof is very long and other people try to find that another theorem that is shorter. So it's also not a matter of proving some theorem, it's also a matter of finding the best, smallest and shortest solution and for answering your question. So sometimes answering your question is just proving some conjecture, but in general mathematics, one of the very important point is finding the shortest solution, the simplest solution for any question. So, and this one, again, depends on if you are in the lower level, in the high school and undergrad. This comes by training. So you learn the skills that how I can solve the questions in the shortest time or in the shortest amount of writing, just by some creativity or looking at symmetry of. Sometimes you don't need to really do a lot of calculation, but you just learn some techniques, for example, to look at the symmetry of the system, some physical system or some mathematical equation. So you look at the symmetry, and sometimes looking at symmetry is, oh, okay, the answer of this question is 0, because I don't need to solve, I don't need to write calculation for 3 pages to get, oh, that is 0. I can just analyzing that and look at the symmetry and say, oh, this is 0. This is one of the examples. But when you are also in the higher level, this is very important that you have to find an approach that you can solve your research projects, the approach to get to your answer in the most beautiful and simple way. And sometimes, if you have enough knowledge of other different fields of mathematics, so then it will help you that you want to solve a question in one topic of mathematics, but then you get help from other topics, and it just make your life much faster, because in that topic you didn't have enough tools. So this is another skill that if you have more knowledge of the different topics of mathematics, so it help you to get some intuition from other topics to help you to solving your problem.
Okay, thank you so much. Yeah, have a good day. Thank you so much for sort of coming to this call and talking to me. It was absolutely amazing. Thank you.
And thank you so much again for the invitation. It was very nice talking with you.